We took a look at the idea of the least squares line and being able to compute the least squares line by using both the calculator as well as by able to use by the formulas. And then we also took a look at being able to use the least squares line to make extrapolation predictions as well as interpolation predictions. We haven't necessarily looked at the validity of the least squares line and also the viability of the points of the least squares line, meaning that how reliable are those points, how much error is involved, etc. And to be able to measure the error involved in the data between the least squares line, we talk about this idea of a residual. Residual is basically going to be the distance between the least squares line, the predicted value, and the actual value, which is the original data set. And you can see in the picture that not every point is going to fall exactly on the least squares line. So this red distance between the point and the line is going to be called a residual. Residual is pretty easy to compute. It's going to be y actual minus y predicted. And we're going to be able to compute something or create something called a residual plot. In a residual plot, we're basically plotting the distance from zero as the y-axis. So this is our response variable. And remember, the response variable is going to be the y value. All right, so that's going to be the original y. And then we're going to plot the residual. In the middle of a residual plot is always zero. So the distance from zero is going to tell us the residual. So in other words, this line right here tells us how far we are. And so does this line, and so does this line, so does this line, etc. Right? If they were connected. Now, the further we are from zero, the more likely it is that we have an outlier. And you can see in this diagram right here that we may have a potential outlier because it is fairly far from zero. Later in the course, when we start talking about z-scores, we'll be able to figure out if this really is an outlier by standardizing the data. All right, but for right now, we're not worried about that. So let's go ahead and take a look at an example. And in fact, we're just going to revisit the example that we just looked at with respect to the hours worked in a week and the profit. And we're going to compute the residuals. We're going to identify the point closest and furthest. We're going to construct the residual plot, and then we're going to determine if there's any outliers. So first thing we remember is that we got this least squares line. Remember, we had 0.586x minus 71.9. All right, so that was our least squares line that we got a long time ago. All right, remember we had that as our least squares line. All right, unfortunately I deleted it, but it's right here in the calculator. So instead of 180, we have x. Right? So we need that first. So before you even do any of the residuals, the first thing you need is you need the y hat equals b1x plus b0. If you don't have that, then you're not going to be able to do anything. So next thing we're going to do is we're going to, first of all, compute the y predicted values. All right, so we already know the actual values. So this is going to be right here, all of the y actual. All right, that's easy. But what are the predicted values? Well, those are the points on the line. And to be able to figure out the predicted values, we're just going to substitute each of these x values back into the original. Okay, so let's just call it y1 is going to be equal to 0.586 times 200 minus 71.9. Y2 is going to be 0.586 times 250 minus 71.9. Y3 is 0.586 times 300 minus 71.9. And then finally, Y4 is going to be equal to 0.586 times 350 minus 71.9. Right? Now we're just going to go in our calculator, and I'm going to show you an easy way to perhaps compute these so that way you don't have to sit there and type this in every single time without using Excel. So what we're going to do is we're going to type in the first one, which is going to be 0.586 times 200 minus 71.9. And we're going to execute. We'll get 41.5. Now what we can do is we can hit second enter. And that just brings up the last command or the last entry. And you're just going to backspace. And instead of 200, 250, enter. Right? So that makes it really easy for us because that way we don't have to continuously enter every single number, and also it reduces the error as long as you got the first one right. We're going to change this to 300 now. And then finally, we're going to change it to 350. All right, now remember the first one's 41.5 because we are going to have to copy these over. All right, so what do we get? We got 41, 3. Oh shoot, I forgot what it is already. All right, so let me copy the other three down, then I'll go and compute the other one. So 74.9 or 74.6 and 103. Nine, and then 133.2. I think it was 43 point something for that one. All right, so let's go back, and we're going to change it to 245.3. All right, good thing I didn't guess. That would have been. All right, so 45.3. Now, each of these are the predicted values. And so what we're going to do is now we're going to figure out the residuals. And the residuals are going to be the y actual minus the y predicted. So we're just going to take 45 minus 45.3, etc. Right? So we're going to make one last table to find the residuals, which are y actual minus y predicted. Now I'm going to call this E1, all right, or error 1 for residual. And that's going to be equal to the actual value, which was 45. Right? So just to make sure everybody understands where we're getting this from, we're just going right up here, and we're taking this 45, and we're subtracting 45.3. So y actual minus y predicted. So go down here, so 45 minus 45.3. E2 is going to be equal to, so we go back up, and we have 73 minus 74.6. And then E3 is going to be equal to 108 minus 103.9. And then finally, E4, 131 minus 133.2. I think it was 133.2. And we're just going to compute these. All right. It's okay if they're negative. Some of them are going to be negative, some of them are going to be positive. So we get negative 0.3 for this one. And then for the second one, we're going to get 74.6 minus that. So that's going to be a negative 1.6. For this one, that's going to be 4.1. And then finally over here, when we subtract, that's going to be negative 2.2. One way to check this is to add these up. All right, so let's go ahead and add those just to show you what happens. So we have negative 0.3, and we have negative, what was it, 1.6, I think. And then we had 4.1, and then we minus 2.2. All right, we get 0. If that doesn't equal 0, that means you've done something incorrectly, unfortunately. All right, so that's our residuals. All right, and that's actually part A for this entire problem. All right, now part B asks us to find the point that's closest and furthest. Okay, so what we do is we ignore the signs or the residuals when we're trying to find the point that's closest and to find the point that's furthest from the least squares line. Because remember, it's going to be above and below, and the distance is an absolute value. So really what we want to do is we just want to ignore all the signs, Not sure what happened there. So we're going to ignore the signs here, and we're just going to go through and we're going to figure out which is the smallest and the largest. And this is clearly going to be the smallest. Okay, so smallest residual is E1. The largest residual is going to be E3. Okay, and again, we don't care about the sign. All right, if it was truly smallest with the sign, it would be negative 2.2, but we don't care about the sign, so it's going to be E3. But that's not the point. The point that's closest is 0.1. And now you see why I numbered them, so that way we can just go back and we can look at the points. The largest point is going to be 0.3. Right? So we're looking at the ordered pairs to find the points that are closest and the points that are furthest. So the point that's going to be closest is the first point on the line, which is going to be 200 comma 45. So it's an ordered pair just like in algebra. So this is 0.1, this is 0.2, this is 0.3, and this is 0.4. So the point that's going to be closest to the least squares line is going to be that 245 comma. So this is 200 comma 45. That's closest. The one that's furthest is 0.3. So that was going to be 300, and I think it was like 108 or something like that. Yeah, 300 and 108. So 0.3 is the one that's going to be furthest, and 108. All right, so that's how we figure out which point is closest and which point is furthest. Right, by looking at the residuals. All right. Now we're going to construct a residual plot. All right, and the residual plot, we're going to need the actual residuals. So we're going to copy these numbers down. And we need the y actual values. All right, so let's just go ahead. I'm going to copy all of this to make it really easy for us. In fact, I can just delete this. That'll make it a little bit easier because it doesn't really matter. So we keep the residuals, and we're going to make a residual plot. So this is part C. And for our residual plot, here's how we're going to do this. So remember, our y actual values were 45, 73, 108, and 131. All right, so it doesn't really matter. Let's just call this E1, E2, E3, and E4. All right, so it's actually categorical. All right, so this is the number of the residual. All right, so it really doesn't matter that much as to you know, what the value of the y is. But what does matter is the residual. So what we're going to do is we're just going to draw this hyphenated line, and that's 0. All right, and this is the actual distance for the residual value, which is the residual plot. So E1 was negative 0.03. All right, so and notice that it goes up to 4. So let's just do 1, 2, 3, 4. And then -1, -2, -3, and -4. And notice that the first point is negative 0.3. All right, so we're just going to plot that right here. And what I'll do is I'll plot them in a different color. So that way we can see like what the residual plot actually looks like. All right, so this is E3 right about here. The next one's negative 1.6, so that's going to probably be right about here. Then we have this 4.1, which is way up here. All right, and then finally negative 2.2, which is maybe right about down here. All right, now, not sure how that moved. I'll fix that in a minute. Not sure how this moved, but Excel has a funny way, or not Excel, but Word has a funny way of playing tricks on me. All right, so this is that negative, or that positive 4.1. All right, and each of these are the residuals. And what we're looking for was we're looking for any point that might be suspicious or kind of far away. And I think it's pretty obvious that this point is pretty far away from the rest of them. All right, the rest of them are pretty close to this line, all right, of 0. All right, so if you have a really short, not too bad, but this one's kind of suspicious. It's kind of way up there. All right, and I bet you if I would have drawn my axes even more even, then I probably would have had even a better residual plot. All right, so to answer the question, which is part D, and the question asks us, based on the residual plot, do you feel there are any outliers? If so, identify the pair. Well, it looks like the third one, all right, and remember the third one was this furthest pair, this, I think it was 108, and then I think it was something like 300 and 108. So it appears that E3 may be an outlier from the residual plot since it is far away, or is relatively far from 0. Okay, and when you say relatively, that means compared to the other ones. All right, and so that means that the point, which is P3, and remember P3 was going to be that 300, 108, may be an outlier. Right? In other words, we call it suspect point, right? Because we're suspicious of it, but we don't necessarily have the mathematical competency yet to be able to determine whether or not it's going to be an outlying value. Right. So hopefully this gives you a good overview as to what residuals are, what residual plots are, and then being able to utilize the residual plot to determine whether or not we have suspicious outliers or suspect points. The last video, we're going to just take a look at throwing everything that we've learned together about least squares, lines, predictions, and then residuals.